Welcome students. So now we are going to discuss and learn about the remaining part of the networking techniques. And now we are going to talk about the development of the CPM model or the model based upon the critical path method. So you call it as when you talk about the critical path development or maybe the CPM. So we can understand that the CPM is applied to the projects which are more deterministic and the amount of risk involved in these projects is not very high, right? So they are maybe used for the projects which have the deterministic orientation where most of the things are pre-tested and we know that if we start working on that venture we will be able to reach at the end, and the amount of the uncertainty would be very less. Either there is no uncertainty, or if it is there, then that would be very less. So in those kind of the projects with the deterministic orientation, we are going to apply the CPM model, and with the help of this process, when we are developing the critical path by using the CPM, so we have to very clearly understand that the difference between the PERT and CPM. So we have talked at length on the PERT and CPM differences, but as we know that PERT model was developed for the projects by characterized by the uncertainty, right? The product PERT model was developed for the projects characterized by the uncertainty, and the CPM model was developed for the projects which are relatively risk free, right? Again we will listen to this and we will try to understand it. PERT model was developed for the projects characterized by the uncertainty, and CPM model was developed for the projects which are relatively risk free. While both the approaches begin with the development of the network and focus on a critical path, the PERT is probabilistic. The PERT is probabilistic and the CPM approach is deterministic. This does not, however, mean, be careful about this part. This does not, however, mean, be careful about this part, that CPM analysis, that in the CPM analysis we have the single time estimates. That's not the case that we have the single time estimates. We can have the multiple time estimates also, and in fact the principal focus of the CPM analysis is on variations in activity times as a result of changes in the resource assignment. So we try to find out that how much time we can vary, how much time we can reduce. If we are ready to employ more resources, invest more resources in terms of money, in terms of the direct cost, not direct cost, not indirect cost, in terms of the direct cost, if we are ready to employ more resources, can we reduce the time? So if you increase the resources tremendously, so in that case the time can be significantly reduced, right? So there are no 3 time estimates, that is a TO, TM and TP. That kind of the estimates are not there. But the objective here is different, that we want to find out the most, you can call it as the suitable time or the minimum possible time depending upon the resources. And directly there is a link that if we have the high amount of resources, easily available amount of the resources, so you can crash the activities and you can bring it down to them to the earliest occurrence time. But if you have not large amount of the resources, even the medium resource amount of the resources, you can crash the activities accordingly and you can bring them to the medium amount of time. But if you do not want to increase the investment of the resources, then normally you have to go by the say the normal time period which one activity is going to take, and within that frame we can control the overall duration of the activity, but there is no effect of any kind of the resource increase or use of the increased resources, so that the time period involved in the activity can be crashed significantly and the project can be completed in the minimum duration. So like PERT means there we have the multiple time estimates, and we have seen the 3 time estimates TP, TM and TO, or TO, TM and TP. Like that kind of the estimates are not here, but here we have the multiple times. So depending upon the resources available with the firm, you can reduce the time, and if the resources they do not want to increase, then they can use the normal time of the activity which is it's going to take for the given amount of the cost. So this difference you have to understand it very carefully. There is no risk involved. There is no standard deviation, sigma kind of the thing we have to calculate here. We know here that the normal time is given to us because the project is with a deterministic orientation. So one time is given to us. If you do not change the resource allocation, you can achieve that say objective in the given amount of time. But if you want to reduce the time, you have that flexibility. You can reduce the time by using the CPM if you increase the resources. right? If you want to decrease the time, if you minimize the time, you can increase the resources. So, that way there are the multiple time estimates, not like PERT, but we have the multiple time estimates, and depending upon the resources you can have the minimum time also and you can have the maximum time also, right. So, these variations are planned and related to resource assignment and are not caused by random factors beyond the control of the management, as in case of the PERT analysis, right. They are not affected by the random variables, not by the random factors. We can control them, but the control of the time is only related to the resources. If you have more resources, if you can increase the resources, you can increase the direct cost, you can reduce the time. That way the flexibility in the timing is there, but not affected by the random variables, and any amount of the risk is there in the projects, like the projects where PERT is applicable. In the CPM projects, or the projects where the CPM can be used, they are more deterministic, but does not mean that they are working on the single time estimates. Time can be increased or decreased depending upon the resources we are employing. And finally, our objective is the main thrust of the CPM analysis is clearly written here. The main thrust of the CPM analysis is on the time cost relationship, and it seeks to determine the project schedule which minimizes the total cost, right. Project schedule which minimizes the total cost. So, objective is on the cost also, because total cost will be minimized. So, the direct cost is increasing, but the total cost will be minimized if you reduce the time. How that will happen, I will discuss with you in the subsequent slides. So, there is a twin objective. If you are going to reduce the project duration by crashing some of the activities and finding the most optimum time, that within this time that activity can be completed and all the activities can be completed. So, what will happen? Your total time period involved in completing the entire venture would be going down. As a result of that, direct cost will increase because it has an inverse relationship, but indirect cost will come down because it has a linear relationship. Longer the duration, higher the indirect cost, and shorter the duration, lesser the indirect cost. So, the direct cost goes up, indirect cost goes down. So, when the duration of the project is decreased or is lowered down, in that situation the total cost of the project remains as the lowest or as the minimized. How that is going to happen, we are going to discuss that in the subsequent discussion. So, first we have to take the assumptions underlying CPM analysis. So, for this particular thing, when you are applying the process of developing the critical path, so we have to take these different assumptions, and these assumptions are: number one, the cost associated with the project can be divided into two components, that is the direct cost and indirect cost. As I just told you, direct cost increases with the reduction of the time, indirect cost comes down with the reduction in the time. Direct costs are incurred on the direct material, direct labor and direct overheads. However, maybe the indirect cost, but the indirect cost or consists of the overhead items like indirect supplies, rent, insurance, managerial services, etc. Right. So, direct costs and indirect costs. Direct costs are incurred on the direct material, direct labor and direct overheads, and indirect costs consist of the overheads like the supplies, rent, insurance, then managerial services and so on. Number two, activities of the project can be expedited by crashing, which involves employing more resources, right. This is very important thing. We will learn practically, but you have to increase the resources say employed in the project. Number three, crashing reduces time but enhances the direct cost. As I just told you, that reduces the time but enhances the direct cost because of the factors like overtime payment you are going to pay, extra payments you are going to make sometimes for the increased supply of the resources, and wastage also, because you are doing the many things in the shortest possible time. The relationship between the time and direct cost can be reasonably approximated by the downward sloping straight line. We will see the structure in the next slide, right. Whereas, indirect costs associated with the project increases linearly with the project duration, right. So, there are the two costs, direct and indirect costs. So, one has the inverse relationship and another one has the linear relationship. So, in this case you can understand these are the two structures, direct cost and indirect cost. So, you see that when this is a normal time, right, and this is the total, you can call it as the direct cost, it is up till at this level, right. But when you are going to crash the time and you are going to bring the duration from this to this, certainly the cost is becoming something like this. So this is going to be, time is going to be reduced, the cost is going to go up, direct cost is going to go up. So it means with the reduced time, higher direct cost, it has the inverse relationship. Whereas in case of the indirect cost, it moves linearly with the time, right? This line is moving with the linearly with the time. So longer the duration of the project, higher would be the fixed cost, indirect cost. But if the shorter the duration of the project, it will come down to this side, otherwise go to this direction. This has the inverse relationship, this has the direct relationship. So direct cost has the inverse relationship, indirect cost has the direct relationship, linear relationship. So because of the direct cost, when you reduce the time, direct cost will go up, but this cost will go up, right? But this cost will come down. So because of this, you call it as it's a kind of a diversification which we normally do in the portfolio construction. So same is the kind of the influence we are finding out here on the project. Because of the duration, your direct cost is going to increase, but the indirect cost is going to go down when you are reducing the duration of the time. And finally, the total cost of the project remains as lowest or the minimized one. So we will have to now see the procedure that how you can develop the, you can use the CPM analysis and how you can maybe have that kind of the, say, the path which is called as a critical path. So finally, it is written here that bulk of the CPM analysis is concerned with the relationship between total direct cost and the project duration, right? And what is the procedure involved is that is given here. So it is the relationship between the total direct cost and the project duration, right? So if you want to, if you can increase the direct cost, you can reduce the duration, but certainly must be sure about that overall, say, cost of the project will come down, even the direct cost increases when you crash the activities and find the critical path, which is though the longest path, but can be completed in the minimum possible time. So the net effect would be that overall cost of the project would go down. So what is the procedure involved? Obtain the critical path in the normal network and determine the project duration and direct cost. So normal, first of all, you develop a structure like this and find out a critical path in this structure. This is a normal path, right? After that, now you start your job, crashing of the activities, trying to find out where the slope is the least, minimum between the time and cost. The slope is least. You crash the those activities one by one and finally find out the critical path. Then number 2, examine the cost time slope of the activities on the critical path and obtain the crash. Examine the cost time slope of the activities on the critical path obtained. Examine the cost and time slope of the activities on the critical path obtained and crash the activities which has the least slope, Then construct the new critical path. After crashing as per the step 2 and determine the project's duration and the cost, and continue repeating the step, that is 2 and 3, till all the activities on the critical path are crashed, and finally the final critical path is found out with the minimum duration and minimum of the cost. So let's go for the steps once again. Obtain the critical path in the normal network, determine the project duration and direct cost. Then examine the cost time slope of the activity on the critical path obtained and crash the activity which has the least slope. This is the most important thing for us. Construct the new critical path as per the step 2 and determine the new duration and the cost. Repeat the steps 2 and 3 and continue crashing the activities till the time all the activities are crashed and the critical path is found out with the minimum duration and the minimum cost. Now we will understand with the help of this example, and this example is very interesting and is going to clarify all the doubts. So in this case, we are going to learn about is that the activities duration and the direct activity cost of the project is given to us. What we are given is, we are given the activities duration and direct activity cost is given to us, and indirect cost is also given to us, which is 2,000 rupees per week. So in this case, we are given the information about the activities. So these are the activities here: 1 to 2, 1 to 3, 2 to 4, 3 to 5, 2 to 5, 4 to 6, 5 to 6, 6 to 7 and 5 to 7. Then we have given the time period. Normal time period is also given, crash time is also given. Then we are given the cost. Normal cost is also given, crash cost is also given, and cost to expedite the work per week is also given, right. So, all this information is given. So, the activities, duration and the direct activity cost of the projects are shown below. So, on the basis of this information, we have to develop a structure, a network, and on the basis of that, we will have to calculate the critical path, the duration of the critical path, which will be the longest path with the minimum duration, and the cost. Now, let us see, these are the structures. These are the project network structures which are already developed here. Because of saving the time, we have to use these already developed structures. And mind one thing, that I have taken these structures directly from the book Projects Prasanna Chandra. This is the solved example there in that book. It's a very interesting and value adding book. You should also follow this book. So, I am using these structures directly from that book, so that we can save the time, because purpose is understanding the concept of networking techniques, nothing else. So, for that reason, I have taken the ready-made structures, and for that purpose, for example, you see, as I told you, first step was develop a normal path, right. Normal structure you can call it, as a normal network which was given to us. First step was obtain the critical path in the normal network, determine the project duration and the cost. So, now from this particular illustration, we are going to misunderstand this whole process. So, project critical path means this structure is, the first structure is this one. This is the beginning of this developing the structures. This is the first one. In this, the critical path is what? 1, 2, 4, 6, 7. 1, 2, 4, 6 and 7, and the duration of the path is 30 weeks, and the direct cost involved is 45,200 rupees. You can easily find out from the information given in the illustration that time period involved is 30 weeks. So, it means you can say here that it is 8 plus 9 plus 3 plus 10. This is 8 plus 9 plus 3 plus 10 weeks. So, you can say total it becomes 30 weeks, and total cost if you see against these activities. So, you can understand the total cost in this structure comes up as the 45,200 rupees, which is already given to us. This is 45,200 rupees. This is a normal first structure network, which is a critical path we have developed here without crashing any activity, without reducing any time or the cost. We have not done anything so far. From here, now we will start the process of minimizing the project duration and follow the process of crashing the activities. But for crashing the activities, you have to see the slope between the time and cost. It is given a condition here. You have to have examine the cost and time slope. This is the most important thing. Which activity will you crash? That the slope means the time and cost slope must be least. So, when you see here the first crashing we are doing of the activity, that is 2 to 4. When we crash this activity, because the slope between the time and cost is the least here, so new critical path comes up as 1, 2, 5, 6, 7, and the total duration is 29 week and direct cost is 46,200 rupees, right. Then we try to find out that what is a new critical path. This is a new critical path 1, 2, 5, 6, 7. And on this new critical path, is there any activity which can be crashed having the least slope, that is a time and cost. As far as the time and cost is concerned, that slope is the time and cost slope is the least, because it is clearly given that the cost and time slope should be the least. So, is there any activity where the time and cost slope is least? So, we find out that this activity 5 to 6 is the one where the slope is the least, and maybe you call it as the cost, maybe the difference in the cost because of the reducing the time, the increase in the cost, the slope between the time and cost is the least. So, 5 to 6 is the least, and after crashing this activity, we get a new path, that is 1, 2, 4, 6, 7 with the duration of 27 weeks and 49,500 is the total cost. Now, on this critical path, we will again find out, because all the activities are not crashed on the critical path, and our objective is to crash all the activities on a certain path, which becomes the critical path. That we will finally say that this is our critical path, and shorter than this path there cannot be any other path. So, on this path 1, 2, 4, 6, 7, now we will try to find out which next activity having the least time and cost slope. So, this is 1, 2, 2, and we will crash this. Once we crash this, so new path comes up as 1, 3, 5, 6, 7, duration becomes 24 weeks and the cost becomes 52,500. So, mind one thing, duration is getting down and the cost is going up. This is a direct cost. So, this is the inverse relationship. So, it is happening here. Then we go for the next structure, crashing. So we have got this critical path now 1, 3, 5, 6, 7, and on this critical path we try to find out which activity can further be crashed. And for crashing this activity, we find out that for crashing this activity, we crash this activity now 6 and 7. When we crash this activity having the least time and cost slope or the cost and time slope, so we find two critical paths 1, 3, 5, 6, 7 and 1, 3, 5, 7. Duration becomes 21 weeks and cost increases to 55,200. Next step is that now on these two critical paths, that is 1, 3, 5, 6, 7 and 1, 3, 5, 7, we have to find out that which activity is there which can be further crashed. So we could find out there is one activity, that is activity 5 between events 3 to 5 or activity 3 to 5. We could find out that activity 3 to 5, we could find out that this is a common also in these two critical paths, and this is having the least slope also, so we crashed it. And finally the new path was found out, that is 1, 2, 4, 6, 7 with the 20 weeks of the duration. So duration has come down from 30 weeks to 20 weeks and the cost has increased from the 45,200. What was the original? 45,200 to 56,400. Now we got the second last path, because almost on this path if you see we have crashed the activities. If you see this path, so on this we have crashed all the activities, only one this activity is left, 4 to 6 is left. So finally we will go for this and we will look at this, so that on this path, because this is a critical path now 1, 2, 4, 6, 7, 1, 2, 1, 2, 4, 6 and 7. On this path one activity 4 to 6 is left. If we crash this activity on this path 1, 2, 4, 6, 7, so we have a new path or a new network we have, and here the critical path comes up as 1, 2, 4, 6 and 7. All the activities are crashed on this, so this has become the longest path now with the minimum duration. Other than that there cannot be any path which is called as a critical path having the minimum duration, though the cost has increased from 45,200 to 57,600, but the duration has significantly come down from the 30 weeks to 19.5 weeks. And finally our critical path has emerged as 1, 2, 4, 6, 7, and this critical path is finally called as the final path, that you have to complete all the events falling on this path 1, 2, 4, 6 and 7, then only the project would be completed. And for completing this project, which is can be understood with the help of this critical path, is having the duration of 19.5 weeks, and direct cost involved here is, that is the 57,600, that is 57,600. So this is how the network structures can be developed. And now finally see the final analysis. The final analysis here is the project duration and the total cost for the given project. So we could see here the activities crashed, right? This is the activities crashed, this is the project duration in weeks, this is the total direct cost, this is the total indirect cost, and this is the total cost, right? So we have seen here that originally what was the case? This was the original case, that is the no activity was crashed, original duration is 30 weeks, cost was 45,200, and fixed cost we have found out is, the original information given was that it is 2,000 rupees per week. So how many weeks? 30 weeks into 2,000, so the 60,000 is the fixed cost. So total cost of the project becomes 105,200 rupees, 1,05,200 1,05,200 rupees is the total cost of the project. If it is on the normal duration, normal direct cost and the normal indirect cost. No crashing is done, no critical path is found out, and we are ready to misuse the 30 weeks time, and we are only ready to invest 45,200 as the direct cost and 60,000 rupees as the indirect cost. So total cost is going to be 105,200 rupees or 1,05,200 rupees. But when we saw that there is a possibility of reduction of the time, so we started crashing the activities, right? So we crashed activity 2 to 4 first, so we found out the time come down to 29 weeks, but the total cost and the total cost has also come down to 104,700. Then we crashed the next activity and the time period came down to 27 weeks and total cost further reduced. And then we crashed one more activity, so duration came down to 24 weeks and the total cost came down to 100,500. 1 lakh 500 rupees. Then it is we crash furthermore one activity, and that is 21 week duration came down, total cost further declined to 97,200. And then further we crash one more activity, so the cost further declined to 96,400. And finally we crash one more activity, so final duration became 19.5 weeks, 19.5 weeks, and the total cost is now 96,600. Now you see this cost behavior. One cost is directly you can call it as one cost is completely inverse to the time, and another one is a linear to the time. So as the time is getting down, cost is increasing, that is the direct cost. It has inverse relationship. But as the time is getting down, indirect cost is also getting down, that has a linear relationship. So it means because of this inverse and linear relationship of the direct and indirect cost to the duration, the final cost, the total cost of the project tend to go down. And finally, for the lowest duration of the project, that is 19.5 weeks, we could find out that the final duration here is, that is the say a final duration is 19.5 weeks, and for this duration the final cost of the project is 96,600 rupees. So this is how the PERT and CPM works and how these techniques can be used. So this CPM was developed by the American company, very famous company DuPont, and this PERT is also developed by the American companies. So it means both these techniques are developed in US, but these days they are very helpful in developing the critical networks for the projects and understanding in advance that how many activities and events are involved in any project, how the overall affairs of the projects can be controlled, and how the project can be completed in the minimum duration and at the minimum cost. PERT is applicable to the risky projects or the projects which are surrounded by the uncertainty, and CPM is used for the projects where there is no uncertainty. Largely the projects are of the deterministic orientation, and finally we know that if we start working on that, we will be able to reach at the end. So with that level of the certainty, we can use the CPM for the projects where the level of risk is very low and they are largely certain kind of the ventures. Now after this, before we complete the discussion on this networking techniques, now we will be learning something about the cost part here. And when you talk about the cost part here, so we are going to talk about is a network cost system. So network cost system was actually added later on. Initially there was no network cost system. Initially we had the structures with the time estimates only, and objective was to minimize the time of the completion of the project. As a result of that completion of the minimizing the time of the project, if there was any reduction in the cost, then it was fine. But specific focus on the cost reduction or developing the network cost system was not there in the beginning. When in the 50s, you call it as mid 50s, these PERT and CPMs were developed in US, right? But later on, to refine the techniques and further to supplement these techniques with the next part, so the network cost system were also developed and associated to these PERT and CPM systems. So now this network cost system helps us to find out whether the project is going to be completed at the expected cost or the cost is going to increase and there is going to be any kind of the cost overrun. When the actual cost is more than the budgeted cost, finally when the project is completed and you incur the actual cost more than the budgeted cost, so that cost is called as the, or that situation is called as the situation of the cost overrun. But if you are able to complete the project at a cost lesser than the budgeted cost, means the actual cost is lesser than the budgeted cost, so we call that situation as the situation of the underrun, right? So one is the cost overrun and one is the cost underrun. Same is the case with the time also, time overrun and the time underrun. So cost overrun and time overrun, cost underrun and time underrun, these four concepts rather, were found out on the basis of the network cost systems. So we have to check with the help of the network cost systems that whether we are going to complete the project at the expected time or at a time which is before the expected time. So we are going to have very positive thing, that is a time underrun, or we are going to complete it after the expected date. So we are going to experience something you call it as a negative aspect, that is a time overrun. And when the time increases, right, when the time overrun is there, cost overrun is obviously is ought to be there, right. With the help of the network cost systems, we can know in advance that how to complete the projects either on time or before time, either on time or before time. So, network cost system, which was supplementing part to the networking techniques which were initially developed on the basis of the time estimates, is going to be very helpful and going to help us to understand whether the project is going to experience any cost or time overruns or underruns or not, or we are going to complete the project on the expected time. So, as it is very clearly given here that techniques of PERT and CPM discussed earlier are essentially time oriented. They seek to answer the questions like what the PERT and CPM, when they are time oriented, what they do. What is the most desirable time schedule? What is the most desirable time schedule? Number one, means most desirable time schedule of the activities. Number two, how much time would it take on an average to complete the project, right? And third thing is, what is the probability of completing the project in a specified time? These are the three important questions. These are the three important questions which are answered by these two techniques which are largely time oriented. First thing is, what is the most desirable time schedule of activities? How much time would it take on an average to complete the project? And third is, what is the probability of completing the project in a specified time? So, everything is in terms of time. Largely, it's a time orientation initially, and it was in these two techniques when we were developing the networks to see the overall behavior of the project growth. So, it was mostly the time centric, and we were more concerned about that how much time is going to take to complete the venture, to complete the project, and we were not more linked or concerned about the cost part. But later on we added the cost part of it, and now it became the network cost system, which we are going to discuss and understand in detail. So, network cost system is what? Such analysis largely overlooks the cost aspects, right? Means such analysis, when you talk about this one, when you are talking about the network cost system. So, it means when you are going to understand the network cost system, so it means such analysis. Which analysis? The PERT and CPM, which is the time oriented analysis, right? Entire analysis, because everything is time oriented. What are the questions here? That most desirable time schedule of an activity, how much time would it take, and probability of completing the project, right? So, such analysis largely overlooks the cost aspects, which is usually as important as the time aspect, and sometimes even more. Sometimes you can give more time to develop the project or complete the project, but if you are to give the extra cost, it may be difficult. So, if you are able to save the cost by increasing the time little bit, I think you will choose the later part, that you would be maybe saving the cost and you can allow little more time if it is not exponentially increasing. So, when you see the PERT and CPM's original orientation, that was time centric. That is why it is clearly written here that such analysis largely overlooks the cost aspects, which is usually as important as the time aspect, and sometimes it is more useful because cost includes money, resources. So, we can save the resources by spending if some more time if it is possible. Next thing is to provide a vehicle for the cost planning and control of the projects. The network cost system was developed later on, right. This represents a very useful supplement to the traditional time oriented network analysis. This is addition, this is a corollary, this is addition to the time analysis or the network techniques which were time oriented. And now we are going to learn about, let us look at the cost projections and the cost analysis and cost control. So, we are going to learn now in the subsequent slides, we are going to learn about the cost projections, cost analysis and control, cost control under the network cost systems. So, this is going to be the objective of learning about the network cost systems, and this cost system is, which is addition to the time oriented PERT and CPM networking techniques. So, we are going to learn about that, how we project the cost, how we analyze the cost, and how we control the cost. So, cost projections. When we talk about the cost projections, so the basic principles of the network cost system is fairly simple, that costs are planned, measured, analyzed and controlled in terms of the project activities. That is the first requirement, that costs are planned, measured, analyzed and controlled in terms of the project activities means not only time but the cost also. There only you are only measuring the time. In the original analysis of PERT CPM, you were only focusing everything on the time, total analysis on the time, but now we are going to include the cost also, where we are going to plan the cost, measure the cost, analyze the cost and control the cost associated to the project activities. Once the costs are estimated in terms of activities, cost projections can be made for any chosen schedule, means whatever the network we have developed. So, we can, because first you have to develop the activity wise cost. Once that activity wise cost has been developed and the structure we have, that network which we saw, that has also been developed. So, now we can try to apply that cost projections. We can try to go for the cost projections on the basis of the activity based cost and on the basis of the network which is developed. For cost projection, it is usually assumed that expenditure for any activity is incurred evenly over the duration of that activity, though it may not be practically possible that all the expenditure you are evenly incurring for that activity during the duration of that activity, but it is assumed that we will be evenly distributing the total expenditure, the cost which we have estimated on that activity. That is normally assumption, but practically it may not be possible, but it does not affect the overall cost estimation about that activity. And in this case, for the you call it as the project progresses, the following may be measured or estimated. So, it means in this case, but we are going to estimate or measure as the project process progresses. We have developed the structure also, we have calculated identified the activities also, we have identified the events also, we have developed the structures also and we have estimated the activity based cost also. So, we have to now find out that say on all the activities, first thing is the cost incurred till date. Has any cost been incurred till date or just we are going to start afresh? So, that is the first requirement. Number 2, what is the budgeted cost till that particular point of time when we are starting the analysis? What is the budgeted cost till that particular point of time? Normally, when we go for the analysis and control of the cost by using the network cost system, we start working at a level when the project is almost half done or part of the project is done, so that we can know the progress part. That is why it is written here, cost incurred till date on all the activities. What was the budgeted cost? That should also be known to us, and value of the work done. This is the next thing, that is the value of the work done. So, you can easily find out that the budgeted cost is, for example, 80,000 and the value of the work done is the 60%. So, it means the work worth 48,000 rupees has been done. It means there is a cost overrun, and you can easily find out the cost overrun. That is the formula is actual cost minus the value of the work completed divided by the value of the work completed multiplied by 100. And similarly, you can calculate the time overrun or the underruns also. So, what is the process involved? First of all, because we are not starting in the beginning, we are not going for the cost analysis in the beginning, we are starting after a certain time. Maybe by that time the certain amount of the work on the project has been done, either 25% of the work has been done or 30% of the work has been done or the 50% of the work has been done. Only then you can go for the cost analysis, and in that case you have to follow these 5 steps. You have to calculate the cost incurred till date on all activities, what was the budgeted cost and what is the value of the work done. With the help of this formula you can calculate, is there any cost overrun or underrun. So, in this case, for example, the actual cost is more than the value of the work completed, the project is under the cost overrun. But if it is a reverse, that is the value of the work completed is more than the actual cost, means the project is under the this cost underrun. It means efficiently the cost has been incurred or the resources have been used. Similarly, next step is we have to use the time overrun and the underrun till date. So, after understanding this process, you can understand with the help of this structure how the cost analysis is done with the help of the project cost networks. So, in this case you understand this structure. This structure is showing you 3 lines. One is showing the value of the work done, this line is showing value of the work done, right. This line is showing the budgeted cost and this line is showing the actual cost. And this is the time period over the months and this is the cost in the millions, which is going on the x-axis. We are showing the time, and on the say y-axis, we are showing the this say horizontal and vertical. Horizontally we are showing the months, and vertically we are showing the this cost. So you can understand that this duration and the cost relationship. So value of the work done, budgeted cost, and the actual cost. So when these three costs are given to us, then on the basis of this we can try to find out whether we are in the state of the say in the state of the cost overrun or the cost underrun, or the time overrun and the time underrun. So you can easily understand these points written here. It may be noted that D curve, this is the curve D, right? This is the curve D, is derived from B and C. This is the B and this is the C. It is derived from the curve B and C. The vertical distance between curves B and C is divided by the height of the curve C and multiplied by 100 to get the curve D. Similarly, this is the lower curve, is this line or this structure is showing you the say the time overrun or underrun. So in this case also we are seeing here that the project is under the situation of the project time overrun, and if it is below the line, then it would be the curve is below the line, then it is project is enjoying the time underrun, but presently it is facing or it is suffering from the time overrun. So both the overruns are there, cost overrun is also there, time overrun is also there. And for calculating the time overrun, you can see that curve E is derived from curve A and C, right? The curves A and C are here, A and C here. So C is most important for both the situations, A and C. The months behind or ahead at any particular point of time is simply the horizontal distance, of the curve C at that point of time and curve A. So you can understand that easily from this situation, if you have got the information or maybe the information about the value of the work done in the quantitative terms, the budgeted cost in the quantitative terms and actual cost in the quantitative terms, the information about the months and the cost. So by developing this kind of the structure on the say horizontally and vertically, so you can find out that what is going to be the situation, whether the project is in the state of maybe no over or underruns, or the project is suffering from the cost overruns and time overruns as we have seen in the present case, or project is enjoying the cost as well as the time underrun, which is not seen in this case. So anything is possible. Project can be completed on time also, it can have the cost and time overruns also, and it can have the time and cost underruns also. But mind one thing, that if there is any time overrun, if the project is delayed, certainly the cost overrun is ought to be there. So to avoid the cost overruns, we have to complete the project on time as per schedule, and that can be attained with the help of these networking techniques, which are going to be very helpful in controlling the overall affairs of the projects, where you can develop the critical paths, and with the help of PERT and CPM analysis, these two very important networking techniques, and using the further this network cost analysis, by using these important say concepts, you can control the overall progress of the project and complete the project on time. So with this discussion, we will stop the discussion here now. We could complete all the 60 lectures, and I had planned to cover up two more topics also. One topic was, which I have given in the this week wise plan also, that next topic for the week 11 was the forms of the project organizations, and for the week 12 we had planned to go for understanding and learning about the review of the projects, but because of the shortage of the time, that couldn't be possible. So these are two theoretical topics, basically forms of the project organizations and review of the projects. These are the two largely theoretical topics which you can refer to any book. Maybe you can learn from any book, and I would again recommend that you go for the book by Prasanna Chandra, that is the projects. Name of the book is The Projects, written by Prasanna Chandra. That's an Indian book by Indian author, very good author. And you can refer to other books also by the foreign authors, and there are some series of the bulletins or books with the Project Management Institute US. You can use those resources also from the PMI, Project Management Institute. Their resources are also there to learn about the details of the project management. So other than these two topics, that is the forms of the project organizations and review of the projects, we could complete each and every topic and part in detail. I hope you liked the discussion what we did over the different weeks and on the different topics. And for these two topics, for the week 11 and 12, which we had planned originally, forms of the project organization and review of the projects, you can do it yourself. You can update your knowledge and you can go through the book which I suggested to you and maybe any other book, and you learn about these two topics. With this discussion, finally, I would stop here, close the discussion here, and if there is any question, any kind of the doubt, I will be available maybe on email or on the phone or maybe during your discussion sessions during over the different weeks. So, if any kind of the doubts you have, please keep in touch and raise the doubts. And finally, when you complete this certification course, you should have the complete knowledge of the project management, including project selection and its financial aspects. With this, I would say a big thank you to you, and I will stop the discussion here. Thank you very much and see you in the course. Thank you very much.